Today, there's a bunch of things I'm going to kind of run over a little bit on the quick side. They're just kind of basic things you probably most of which you should know, and then we're going to look at exponents, rules of exponents. So I guess I'll start over here, and we're going to talk for a minute about the absolute value. Absolute value of a number. Well, if x is greater than or equal to 0, then the absolute value of x is just x. If x is positive, it's just the number. If x is less than 0, the absolute value of x is the opposite of x, or the negative of x. It's also a positive value, right? So, like the absolute value of 5 is 5. The absolute value of 0, well, that's easy, 0. But the absolute value of negative 3, that would be 3. That's pretty straightforward. You may not have run into this idea that if you have a number line, that the absolute value of a number, say, we'll look at negative 3, is the distance from negative 3 to 0, or what we call the origin. That works whether the number is positive or negative. It's just, you can think of it as a distance. And later in the class, not today, when we see something more complicated, like if we see the absolute value of x minus 3, right? Well, let's say x minus 3 equals 5. That means this quantity here is a distance of I want to get this right. This quantity has to be 5 or negative 5. So x is going to be a distance of 5 from 3. So you don't have to worry about that now. We'll look at that later. So that's really all I have for the absolute value. It's just a starting point. We're going to do more with it later in the class, but you should have that basic down. The next thing is I'm going to go through some basic geometry formulas that I hope you've all seen before. Hello. So the first is the area of a triangle. We have a triangle. It has, you can pick any side you want to call the base. Just as a matter of convenience, we often prefer the one on the bottom, but this could be the base. And then we drop that's terrible. I got tossed out of art school for that. Let's start over. There we go. So this is the base. We drop a perpendicular line, a line at right angles here, and that's our height. And then the area of a triangle is just 1/2 the base times the height. Next, we would have the area of a rectangle. Typically, you could call this the base too and the height, right? Or length and width. And the area of a rectangle is just going to be length times width or base times height. This is going to work fine for a square, except length and width will be the same. So for a square, it would just be, well, we could just say S for the sides of a square, and the area of a square would be S squared. When we get to, does everyone remember parallelogram? Parallelogram, it's kind of like a rectangle squished over on its side, but each of these sides, opposite sides, are parallel. And again, you have a base, and now it's not the length of that other side. Again, you drop a perpendicular to the height, and it's again, the area of the parallelogram is base times height. Does anyone know what we call the four-sided object that's both a parallelogram? I guess I should write that down. Parallelogram. And a square. You got something, it's a square and it's a well, no, that's not right. That's wrong. What I mean to say is, does anyone remember the name of the four-sided object? It's a parallelogram where all four sides are the same. A rhombus, okay. That's a rhombus. Okay. And like the square, you have all four sides the same. The area of the rhombus is just going to be the base times the height. Okay, there's one more formula. These are all things, you should know or jot them down, kind of be aware of them. There may be some homework problems where either they're about this or you need this information. All right, now's when I get my MA in art. Oh, total failure. That's terrible. Well, here we have a circle, has a radius r, and who can tell me the area of a circle? Pi, all right. Times r? Well, all the way through is the diameter, and around is the circumference, and the circumference is pi times the diameter, right? So the area is not just going to be pi times r. That would be like half of this. Anyone remember? Okay, it's not a big deal. It's pi r squared. There's how shall I say it? You can look at these and you can just memorize them, but you can also think a little bit about what the answer must look like. See, here we have, these are all areas that are two-dimensional. So here we have base times height. We're multiplying two features. with a square, the sides are the same, but we have to multiply them by each other. Circumference is just a one-dimensional thing. So, pi is just a constant, right? 3.1415, and then it goes on for a long ways. So the area of the circle is going to have, this two-dimensional feature to it. So I don't know if maybe that'll help you remember. There's a cute little demonstration of this. I don't know. Some of you may like it, some of you may not. But if I take a circle and I kind of cut it up like a pizza, only it's a big pizza, and I have lots of people I need to feed, right? So I cut it up into lots of pieces, and then I unroll it. So it kind of looks like, it's going to look like this. It's going to, and I don't know, I have a lot of pieces here, but I could keep going. I could keep cutting this and, kind of stretching it out. And eventually these little curves here would kind of flatten out. They get more and more like a straight line. Kind of the equivalent of unraveling this. So this length would eventually, it would get to be about the length of the circumference. And then each of these would become more and more like a triangle, with the height being r, the radius. So if you think of this as like a bunch of little triangles, with each having their own base adding up to c, I guess you could, triangle 1 would be 1/2 base times height, base 1, that would be like here, and base 2, 1/2 base 2 height. As you add up all these areas, well, now we can take out the half and add up all the bases. Well, the height is r, right? We said the height is r. And the base is the circumference. Well, the circumference is pi times diameter, or 2 pi times the radius. Oh, so we cancel the 2, and we have pi r squared. So that's, one way to think of how you get the area of a circle. I don't know if that helps to remember it. Okay. I have something in my notes written wrong. Well, it's a good thing I remembered it right. Okay, so that's area. Any questions about geometric area? These are all, again, they're pretty basic. When I give an exam, you have a cheat sheet, so if you feel like, there's one of these that you're not particularly well versed in, maybe you don't remember pi r squared that well, you can put that on the cheat sheet just to remind yourself. I don't know how that'll be real important. So we're just going to go one more step, and we're going to look at volume. And we have this object, it's called a parallel pipe. I just like to call it a brick. Right? Think of a brick. So one side of it is a rectangle, and the top, even though I'm drawing it here in perspective, is a rectangle, and all the sides are rectangles. And you have 3 dimensions now. Now we're dealing with volume, so there's going to always be 3 dimensions. So length, width, height. Well, I guess this should be the height, right? Height, width, length. So the volume of a parallelepiped is just length times width times height. And you can label these however they want, because it's going to be the same formula. Now, if we take this one step further, instead of a triangle, we're going to get what's called a pyramid. Well, we all know what a pyramid is. There's the kind of Egyptian pyramid, which will have a base that has 4 sides. But you could also have a 3-sided pyramid, or a 5-sided pyramid. The volume of a pyramid is the base, the area of the base, times the height, times a factor, which is 1/3. So if the pyramid's a square, right, and the sides are s, it's going to be 1/3 s squared times the height. This is the volume of a pyramid, or this. If you're observant, you might have noticed that for a 2-dimensional object, where we're calling it a triangle, where we take a base and connect the lines, we get the factor half. But for 3-dimensional, we get the factor 1/3. It turns out that's not a coincidence, right? Math often has, these little things you can notice. If you want to get really exotic, and see if I can draw this, and I'm going to draw a hypercube. No, it's not going to be a hypercube. It's just a cube. See if I can do that right. But then I'm like thinking in the 4th dimension, whatever that is. And I pick some point over here. And now this is a 4-dimensional thing where all these lines all go to one point. Well, the hypervolume would have a factor of 1/4. We'd have the volume of the base, and then whatever the distance to this point. They'll all be the same distance because it's off in the 4th dimension. You don't need to know this. Yes?
I just have a question. You wrote volume of pyramid equals to base.
Yeah.
And what's under that? Is that an A?
The area of the base. It's not a length.
Oh, so it's the area.
It could be the area of a square or the area of a triangle.
Oh, like to find the area of the base, we just do 5 times 5.
Well, for a square, you would. I actually meant that to be an S, but it looks a little like a 5. Yes. Yeah. For a pyramid like this is called a tetrahedron. You'd find the area of this triangle and then the height.
Okay.
So,
I see.
all right. Okay, the two more volumes we're going to do. They're both related to circles. If you have a circle as a base, well, the circle is going to have a radius, and the area of the base is going to be pi r squared, and it's going to have a height. And the volume of the cylinder will just be pi r squared times the height. Now again here you can see it's a three-dimensional object. There's three numbers involved, right? There's a factor here of pi, but if someone asks you for a volume and you only have two numbers, you're going to kind of go, wait a minute, how's that going to work? Okay, and then finally we have the volume of a sphere. I don't know. Sphere, a ball, tennis ball, a bowling ball. It's going to have a radius. And our volume of the sphere is 4 pi r cubed over 3. So 4/3 pi r cubed. I'm getting these things wrong on my notes. I don't know, I must have been in a hurry. Maybe I can fix these. All right, so that's your basic geometry, areas and volumes. You need to know those. I assume if I gave you a problem like, I have a pipe, like a water pipe, and it's got a radius of, let's say, 2 inches, and it's 3 feet long. And I said, well, what's the volume of water in that pipe? Assuming the pipe's kind of thin or negligible. Well, okay. Well, we have a problem with units, but we'll get to that. So our cylinder is pi r squared times now the height is kind of on its side. So it's pi, r is 2 inches squared times 3 feet. Well, 3 feet, what am I going to do with 3 feet? I want everything in inches. So how do I make 3 feet into inches? Sorry? Times 12. Anyone who's here from, I don't know if we have any international students. Okay. You don't have to know feet to inches. Centimeters to millimeters, right? A lot easier, right? Okay. So, 36 times 2 squared, 36 times 4, pi times 36 times 4. That's fine. If we were doing like a physics, like an engineering problem, we'd put it into the calculator and use some version of some estimate for pi, and we'd get a decimal number. But we're not interested in that in a math class. Okay. Any geometry questions? I mean, we're not going to do any geometry proofs or any special geometry theorems. This is just our basic areas and volumes. Okay. You don't have to answer, but if you felt comfortable with this, most of this, People, you can shake your head. I mean, if you're not, you can come talk to me, again, after class or office hours. We're not spending a lot of time on this because I assume most of you have run into this at some point. All right. Okay, so the main subject for today is going to be working with exponents. And for now, we're only working with integer exponents, negative and positive numbers and 0. And you have some number, say 5, and you have an exponent, which we write in the upper right-hand corner. We'll say 3. And what this means is we're multiplying 5 by itself 3 times. Now, if we take two numbers with exponents, I don't know, let's say 6 times 6 to the 4th times 6 to the 3rd, well, we want an easy way to figure out what that is. So let's use kind of the definition we've described to kind of describe that. So this first 6 is 6 to the 4th is 6 times 6 times 6 times 6, right, 4 times. And we're multiplying it by 6 to the 3rd. It's 3 more times. So we end up with 6 to the 1, 2, 3, 4, 5, 6, 7, which of course is just 4 plus 3. So we write this as a rule. I guess I'm going to start putting up a list of exponent rules. That if I have some number a to the n, a could be any number. Typically, if I use n or m or j or k, I mean an integer, times a to the m, that's just going to be a to the n plus m. All right. We might have a similar situation. Let's say I have, 7 to the 3 divided by 7 to the 2. And so what do we have here? 7 times 7 times 7 over 7 times 7. Well, we know we can cross out 2 of those, and we just end up with 7 to the 1. But we can see the connection immediately, right? This 1 is just 3 minus 2, right? Whatever the exponent is on the top, we just subtract the exponent on the bottom. Now, this only works because we have the same base. That's this number 7 here, 6 here, 5 here. Okay, so we have another rule, which is that a to the n over a to the m equals a to the n minus m. Kind of a trick question here. Can anyone think of a situation where this is not going to work? There's one situation where it's not going to work. Yeah?
Isn't it if like one of the numbers is bigger, like if the numerator is bigger than the denominator, it won't work?
It will. We're going to get to that in a minute, right? It will. No, there's something else. If a were 0, then 0 over 0 is It's not 0. 0 over 0 is undefined. It's like dividing by 0. We can't do it. I mean, it would be nice. We could say it's 1. It's not. Okay. All right. Well, let's check something out here. According to this rule, if I had say 5 to the 3 over 5 to the 3, what is 5 to the 3 over 5 to the 3? We know what that is, right? It's just 1, yeah, right? Whenever you divide something by itself, you get 1. But using our formula over there, or our rule, it's 5 to the 3 minus 3 is 5 to the 0. Oh. So 5 to the 0 is 1, right? You all run into that? It's a little counterintuitive when you first run into it. So I'm gonna make that its own rule. A to the 0 equals 1. Now, I already said this before, A not equal to 0. What about this? Anyone know what 0 to the 0 is? It would be nice, but it's not. It's undefined. I mean, you could see where already you could argue it both ways. 0 should be 0, right? But wait a minute, it should be 1. It's undefined. Doesn't make sense. Okay, all right. Let's get back to your question. I've got I don't know. I'll just use a different number. 11. No. I've got 1 over 11 to the 3. But wait a minute. 11 to the 0 is 1, isn't it? And now using my formula over there, I get 11 to the 0 minus 3 equals 11 to the minus 3. Oh. So this is what negative exponents are, right? 1 over 11 to the 3 is just 11 to the minus 3. Now, I like a nice, clear way to see that, why that has to be. So I'm going to write over here, I'm going to write n and 10 to the n. So I'm going to start at 3. So 10 to the 3, that's 1,000. 10 to the 2, well, that's 100. 10 to the 1, well, anything to the 1, you're just multiplying it by itself one time. It's going to be 10. And we already saw for 0, 10 to the 0 is 1. Well, what are we doing here each time? Since our base is 10, we just divide by 10, divide by 10, divide by 10. So when we get down here to minus 1, we divide 1 by 10, you get a tenth. You do it again, we get 100. So to kind of encapsulate that all, we have a rule. 1 over a to the n equals a to the minus n. Now, you can interpret this n either as positive or negative, right? So if I have like 1 over 3 to the minus 5, I can just move that up. That becomes 3 to the minus 5. Minus 5 is 5. Right? So it works both ways. All right. Give myself some room here. Okay. Okay. At the end of all this, I've got a horrifically ugly looking problem that we'll just we'll know everything about exponents. We'll be able to just take care of it. Okay, the next thing to look at is, well, let's say I have 4, and I'm going to raise it to the 3 power, which is raised to the 2. Now, you might want to put in some parentheses so you're not unclear as to what this is. All right? All right, so let's think about this. 4 to the 3, that's 4 times 4 times 4. So I'm going to take 4 to the 3, and I'm going to square it. So I have to multiply it again. 4 times 4 times 4. And I end up with how many? 4 to the 6th. It looks like 4 to the 3 to the 2 is just 4 to the 3 times 2. That's exactly right. So a to the n to the m is just a to the n m. Now, sometimes you've got a problem where you can use this both forward and backward in a helpful way. Like if I said, what's the square root of 2 to the 5th squared? Well, that's an ugly problem. We haven't talked about square roots yet, but I'm guessing, square root of 2 times the square root of 2 will be 2. Well, here we can just switch the 5 and the 2. Square root of 2 squared is 2. 2 to the 5th, well, 2, 4, 8, 16, 32. We didn't even need a calculator to write it down. So sometimes this trick here, we'll call it, can be helpful. It's also the case that once you have nm, you're not stuck with nm, right? Like if nm is, 40, you can divide that up however you want. It could be 2 times 20 or 4 times 10, whatever is useful. It all works. Yeah, you see, a to the n to the m is a to the nm, right? If I wrote a to the m to the n, in other words, I switch them, it's still a, well now it's m times n, but that's the same as n times m. See? It's kind of a nice trick. Okay. So that's how to handle something raised to, an exponent and then raised again. You can keep doing this too, right? A to the m, m, p, q, r, you just multiply them together. All right. So now we come to something like this. Let's say 5 times 7 squared. Well, one thing we can do is we can multiply these together. We get 35, and we can square that, right? But, you know, let's for the moment, let's just leave it 5 times 7 times 5 times 7. Well, you know, we can rearrange this. This is 5 times 5, 7 times 7, which is 5 squared times 7 squared. We sometimes use the word distribute. We can distribute this exponent over these numbers. Now you might say, oh, I'm just going to do this on my calculator anyway, right? It's going to come out the same. Why bother? Well, later in the class, we're not going to always be using numbers. We might say like 3x to the 4th. Well, you can't multiply 3 times x because we don't know what x is, but we can distribute. This is 3 to the 4th, x to the 4th. Does anyone know right offhand what 3 to the 4th is? Well, it's 3 squared squared, right? So 3 times 3 is 9, and 9 times 9 is 81. Yeah, okay. I know, you know, I'm the professor up here. I can make it look easy, but all these, you know, a little practice, a little, you know, sometimes you have to get over that hump of numbers in my head. It's not always that hard, right? Okay, so we want to have a new rule here. It says a times b to the n is a to the n, b to the n. Okay. We start playing around with, you know, variables and rationals and functions and stuff. All these will become useful. So we're going to practice them a little. If I had 3/5, a fraction now cubed, well, I know 3/5 times 3/5 times 3/5. I can just multiply the numerators and the denominators, right? And this is just 3 cubed over 5 cubed. So in a fraction, you can distribute the exponent also, right? To the top and the bottom. So we have a over b to the n. That's just a to the n over b to the n. All right. Now we're getting a little tricky here. All right. Say I have 4/7 to the minus 2. Well, okay. I can distribute that just the way I said, the minus 2 over 7 to the minus 2. Now, 4 to the minus 2, I want to use this rule here, right? 4 to the a to the minus n, that's 1 over a to the n. I want to get rid of that minus. So 1 over 4 squared. And I can do the same with the 7th, right? 1 over 7 squared. Well, now I have a fraction dividing a fraction. I think we talked about that last week. What do we do when we want to divide a fraction by a fraction? We Don't all raise your hands at once. How do we divide a fraction by a fraction? You flip it, you get the reciprocal, and you multiply. Oh, over 1. Well, that's 7 squared over 4 squared. Well, now let's look where we started. Oh, we could write this as 7 over 4 squared. That's what I wanted. So it looks like when I'm raising to an exponent, if I change the sign on the exponent, I flip the fraction. So, if I said, what's the reciprocal of 6? Well, that's easy. It's 1/6. But if I said, what's the reciprocal of, 3x over the square root of 5, that's good enough. Well, to the minus 3, right? Well, we just know it's square root of 5 over 3x cubed, right? In other words, changing the sign just flips the fraction. So how do we write that? You'd say a over b to the minus n equals b over a to the n. And we can use, where's our rule? This rule here to take this, and we can say, all right, a to the minus n over the b to the minus n is just b to the n over a to the n. I mean, you could just look at this as, well, if I move the b up, I switch the sign on the exponent. If I move the a down, I switch the sign on the exponent. Now, when we're trying to simplify some complicated expression, especially one with variables, this is really useful. If I have just a quick example here. If I had, 3x to the minus 2y squared z over xy to the minus 2 d squared. My, how quickly the day goes. Well, all right, let me just finish what I was going to say. So I want to get rid of the negative exponents. So I'm going to move these two down, right? But there's 1 here, so I am going to end up with x cubed. I want to move this up, right? So 2 plus 2 is going to be y to the 4th. And I'll move that z down. We just subtract. And then I get rid of my negative exponents. Okay, we're not quite done with exponents. But Thursday we'll finish up. And thank you. I'll be here for a few minutes if you have any questions or you want to turn in homework.